Okay, so these are the notes for 3.3 and 9.4. We're splitting the two sections because there's no one section that just covers natural disasters. You need to make sure that you listen. You need to listen to this because there's going to be a lot of information that I'm not going to write down that you're going to need for lessons later. All right, you want to write down the red. So this is some vocab stuff that we're just going over right now. You have low pressure, which means that it's going to be targeted by the L. It's cloudy weather and precipitation. This is where storms occur. So cloudy, precipitation, and storms. High pressure is going to be the H on a weather map. So we're starting with weather maps first, obviously. It's going to be partly to mostly sunny and calm weather. So we like high pressure systems. That helps. High pressure systems keep the clouds from forming above us. Warm front, you think warm front would be like nice and warm and totally awesome, but it's actually bad. So a warm front is a red line with semicircles on it. The warm front brings in the warm air meeting the cold, which is usually bad weather. So warm front is where the warm air is replacing the cold, and it's bad weather. Now a cold front is going to be the triangles on a blue line, and this is where the cool air, a cold front is the boundary between warm and cold air, where cool air is replacing the warm air. This is also called a dry front. We like this, dry fronts. Yes, it's usually cold, but it's not snowing, it's not raining. Then on the next slide, so if you're not done, pause it. So the next slide, you don't have to copy any of these down. The main ones are on the previous slide. But occluded front, that's the purple. Sometimes it might not be purple, sometimes they might alternate it blue and red. But it's when you have the semicircles and the triangles, because this is when they mix. And it's usually the later stages of a storm's life cycle. So you might see a high front or a warm front and a cold front meeting, and then the purple forms because it's literally them mixing. Stationary fronts occur when it's literally they catch up to each other, and instead of them pushing against each other and one winning, kind of like tug of war, they'll just stay in that spot. And that's usually when a storm can just hover over an area for a long period of time. That happens a lot in our area. You have the trough, which is the dotted line. The dotted line will either be purple or it'll end up being brown, but it's a dotted line nonetheless. And it's when you have the lower pressure at high altitudes or at Earth's surface, and it influences the cloud movement and the precipitation and the formation. So when you see a trough, you know you've got some low pressure and you have some movement going on. So you have a little bit more action there. Okay, so the biggest thing that you need to make sure that you do know is that low pressure is counterclockwise, high pressure is clockwise. This happens because of what's called the Coriolis effect. The Earth spins, if you didn't know that. So when the Earth spins and we would drop something on the Earth, it'll go the direction that it's spinning. And the same thing with the wind. The wind moves because of the Earth spinning. Coriolis effect. So with low pressure systems, because they're going in, they'll turn counterclockwise, and high pressure systems are going out, and that's why they will turn clockwise. So that's why when they meet, when a low pressure and a high pressure system meet, you have opposite winds meeting, and that's how you get a tornado. Because it's going one way, it's going the other, and they end up spinning together. All right, so looking at this is one of the weather maps. So you have the occluded front here in lower Illinois, because you had the low, the warm and the cold front meeting. And you can see you also have an occluded front on the east coast, but they didn't color it purple. So that's one example. Then here you have the trough happening, and you can see a lot of rain around it because that's what happens with the trough. You have that low pressure in the atmosphere keeping the storm overhead. So Midwest, you have the high pressure system, so they have nice weather out there. And yeah, you don't have too much other action going on. A lot of precipitation out east because of the low pressure system. That gives us a lot of storms. And then out west you have the high pressure system. Lots of troughs happening. So a lot of cloud formation, so it's probably really cloudy over in California. Okay, so some maps might give you a bit more information than you need, which is nice, that helps. See here you have the two fronts meeting, and they created this occluded front. Let me change my color really quick, maybe that'll help. Yeah, so you have this two fronts, the warm and the cold meeting to create the occluded. So right here, you have some crazy, crazy action happening because they're both meeting. If you notice, right where they meet, that's the tornado alley. So this whole area, if you look, it creates this corner. The corner that is always in the bottom right here, is when you're going to have the most action, when you're going to have the most storms, the most tornadoes, things like that. That's why in the storm on Sunday, the past Sunday, we had this high pressure system and this low pressure system meeting right over our area, and that's where Cleveland got hit and most of the others, because we were right in that bottom right corner. All right, moving on to the Earth itself. Geosphere is the actual Earth, so there's the crust, the mantle, the core. There's an inner core and an outer core. Outer core is molten, inner core is solid. That's how we create our electromagnetic field, because the inner core is spinning and the outer core keeps it hot. Hot metal moving fast creates an electromagnetic field. Plate tectonics. This is something that we're going to look into a little bit more. These are just some vocab words that might help, so you may want to come back to this video if you get a little lost during plate tectonics. They're basically big sheets of floating rock on lava. Remember, Earth is not solid. Earth is constantly moving. Everything floats on the lava. Think of it like a cup. The water in the cup is the ocean, and the cup itself is actually the plate tectonic. So there are different plate tectonics that you do need to know. We're going to label a bunch of these later, and there's a bunch of vocab words that go with these. Each of these red sections here is a separate plate tectonic. So here's one plate tectonic, 2, 3, 4, 5, 6, 7, and you can see they're all named. So we have the Pacific plate, Pacific Ocean, North American plate, Caribbean plate, South American plate, Antarctic plate. So they're kind of named obviously. With each plate, they are coming together in a different direction. And that's where divergent, transform, and convergent come into play. And you need to copy these down. So divergent boundaries are when you have the plates moving apart and you have this ridge forming. So you've got the magma coming up and the plates are moving apart. This happens between us and Europe. So we have the divergent plate between us and Europe. Transform plate is when they're sliding next to each other. This is California. So you have the transform plate when they're sliding next to each other, and this is California. Don't know why there's a random box there. And then you have the convergent plates. There's two types of convergent plates. There's subduction and mountain building. All right, so what does that actually mean? Either the plates are pushing against each other to create this uplift of a mountain, or one plate is going below the other and it's creating this trough. Okay, that happens a lot in the ocean where you have this trough, and then you have, because of the plate going underneath, it'll push the magma up and create these islands. This is like Hawaii, because you have the islands forming beyond the oceanic crust. Okay, so this is a look at a bunch of the different pictures, and this is really good to look at because you have the different types of movement. I'm coloring over the vocab words. So like I said, subduction. You have the trough forming. Another subduction showing a volcano. So that's how we have volcanoes, is because of the subduction. Oh, more volcano over here. The trench because of the subduction. And then you also have the convergent. I think I used the right vocab word. Divergent. Crap. That's the divergent. So, divergent. There we go. I don't see convergent. They're not showing it. All right, so moving on. The plate tectonic directions, you do need to know this. So that's why these plates are pushing against each other. You have the mountains forming here because the Antarctic plate is smashing into the South American plate. A lot of the plates aren't actually smashing into each other. If you look, they're pretty much moving east. So they're kind of just shifting around the world. We'll look into that a bit more. All right, and then earthquakes. So Earth's crust is broken into larger pieces called the tectonic plates. Earthquakes tend to happen at the boundary lines. So all these red dots in this picture here, that is showing you all of the earthquakes. They can trigger the landslides and the tsunamis and a lot of the resulting weather. So it'll shake, and then a couple hours later we can have tsunamis, and that actually happens a lot. Around here is what we actually call the Ring of Fire, because that's where most of the activity is at, and that's where you have a lot of action. So around here has been really great. If you look at the back wall in the classroom, you'll see that there's a bunch of earthquake activity that happened in February 2013. That's pretty interesting if you want to take a look at that as well. Make sure you have this copied down, if not, pause it. Volcanoes opening in the earth crust. So you can see that they were produced in the back by those, by those subductions, because they're pushing the magma up through the cracks. So you have them here and here. And then you'll have random hotspots, which are like leaks, basically. The Earth's crust is thin, and it's going to poke through because of the pressure underneath the tectonic plate, and that happens a lot. We'll look more into volcanoes a bit more. I basically want you to know that volcanoes were formed from the pressure in the magma and also from the subduction zones. All right, storms. Yay, my favorite part. I'm a huge storm nerd. So tornadoes, rotating funnels of air. This is when usually you have a warm front and a cold front coming together with a low pressure and a high pressure. When you have those two things coming together, it's usually going to create a storm. So when you see a tornado warning, you want to look at that on a map. You want to look for that warm front and that cold front meeting, those two lines, the semicircle and the triangles, and then look for that L and that H coming together. If you have those two things coming together, then you know you're going to have a big storm. And that's why last Sunday I knew that it was going to be big. Not big for our area, but I mean, it produced over 25 tornadoes. That was a huge supercell. And some of these vocab words we will go over later as well. This is what's called the Fujita scale. This tells us how damaging the tornado was. We don't figure out how damaging a tornado is until after it passed. So once it's over, we can actually rate it. And this is by wind speed, and it's also by the damage. They don't have it up here, but it's about how much the tornado eats or the damage that it caused. F5 is total mass destruction. Buildings that are concrete, steel, and force are just demolished and are complete toast. To where an F0 just causes a little bit of damage. It's kind of annoying, maybe some shingles and a couple of branches. So the ones from that past Sunday were between an F1 and F2. The one in Washington was F2, F3-ish. So those were pretty high tornadoes. All right, so looking at this is the map of some of the tornado possibilities. When you are looking at the map on the left, you can see that this is the storm tracker. You have the rain, and you have the thunder, and then I always call the red just the bad. When you're looking at it, you want to look at the red-orange line, and when you see these curves in the red-orange line, like there, and maybe here, if there's a little wind rotation, that will actually produce a tornado. And they actually show that that did produce a tornado. So, oh, there's a video with it. We'll have to look at that later. And on the right, it actually shows you have the low pressure system and the high pressure system. Whoops, didn't mean to do that. Ah, crap. Okay, low pressure system and high pressure system coming together, and you have the warm front and the cold front, so you have tornadoes happening here. Like I said, the bottom right corner. Okay, and then this is looking at an overall map. So you have Tornado Alley, you have the cold air coming from the Antarctic, warm air coming from the Gulf, and this is where you have the perfect mix, because remember, you have this going counterclockwise. Pick a different color. Going counterclockwise, this is going clockwise, so they'll actually stir together to create a huge problem. There's actually been more tornadoes in this area the past couple of years than anything else as well. Oklahoma sees a ton of issues. All right, hurricanes. They develop over the Atlantic Ocean or Eastern Pacific Ocean and over warm water. This is what defines a hurricane. So that's a crappy start. That's a definition of a hurricane. And then you have the Saffir-Simpson hurricane scale. This actually will tell us how devastating a hurricane can be. So we have category 1, 2, 3, and 4. There's only 4 categories for this one. It talks about the winds, and it also talks of storm surge. What that means is the waves that occur, because tornadoes, once they hit land, they usually die out. Again, this is looking at other tornadoes. They track the path of it so they can project the way that it'll actually run. Usually over Cuba it'll probably die off, so that in Florida it won't be that big of an issue. And then you have this massive one. It'll start to die off as it goes up the coast because it's hitting land and it's getting into cooler water as well. All right, that's the end of it. You have questions, let me know.